Hi everyone, I'm Orange. I'm sorry I have to give this presentation in this format, but I can only do this because the US didn't give me a visa. But still, I appreciate all of you who choose to be here, even if this is a pre-recorded video. Also, I don't know if there are actually any people in the audience. No matter what, I have invited our CEO, Alan. Our company provides the most professional rating services in Asia. So if you are interested, feel free to come up and chat with Alan after the talk. Now let's get started with today's presentation. First, I want to ask, is there anyone here who hasn't heard of the Apache HTTP Server before? If so, please raise your hand. Well, I guess I cannot see your hands, but I believe I can skip the introduction. But let's still give you a quick overview. First off, Apache is an open source project that's nearly 30 years old. It might be older than some of you here. And because it has existed since the early days of the internet, it has accumulated a lot of technical debt. Another key point is that Apache enabled CGI by default, which greatly increases the potential attack surface. Lastly, Apache is the only web server that can perfectly integrate with PHP. Because of its high integration with PHP, how many ways do you think there are to set up a PHP environment? There are numerous configurations available. There are over 10 methods just for faster CGI alone, which includes 5 different modules doing the similar thing. This doesn't even count for CGI combinations and the process manager like PHP FPN. Especially since each module has its own directive, all of this multiply the complexity of setting up a PHP. Moreover, some directives not only look very similar, but also have identical usage and effects, which can lead to potential confusion. So if you don't understand the intention behind each directive, it's easy to make mistakes and create security risks. For example, when a sysadmin wants to set out the PHP on his machine, he might come across 2 common directives, add handler and add type. So which one do you think is correct? Actually, both are correct. Both methods can get the PHP running properly. So does this mean both methods are equally good? Firstly, being correct does not mean being secure. And under certain conditions, add type has been proven to be vulnerable, that allowing attackers to disclose the PHP source code remotely. As for why, I will discuss the reasons later. And the last, I believe the most important thing is, no offense, but from my years working in offensive security, I have observed that sysadmin who use Apache tend to have more massive environments. Also, I can't think any reason to use Apache other than for CGI. In practice, many Apache servers are hosting a lot of third-party services like Java Web Server or Nginx locally. They often use rewrite rule to remap the traffic to them. And usually, the file system on the server is also a mess, with lots of strange files sitting on the web root. Today, I will share many techniques. For example, here is a common password-protected manager interface. I will tell you how to bypass it. And I will also tell you how to identify problematic rewrite rules. In practice, sysadmin love to write a lot of config, like this is the rule to hide file extensions. It's vulnerable, and you will learn how to break it today. Lastly, I will introduce the brand new exploitation technique. Here is a simple CGI, and how can this CGI be exploited? First, you might think of using CRLF injection for accesses. But unfortunately, we are not interested in client-side vulnerability. Can you think of any other attacks? Some people might consider attack like smuggling, but there's no middle box here, so attacks like desync or cache poisoning are not feasible. In such scenario, many bug hunters would typically report it as excesses. It is really a waste. But today, you will learn a new awesome way to exploit this. This bug has the potential to become RCE. Before we dive into the topic, let me introduce myself. Hi, I'm Orange, and currently I'm the Principal Security Researcher at DevCore. I have spoken at many hacker conferences like Black Hat, DEF CON, and HitCon. My research has also got numerous honors, such as the first place in Top 10 Web Techniques, Pontoon Champion, and Pony Awards. So first, why focus on Apache? At the beginning of this year, I started to explore some open source projects with widespread internet impact, such as Apache Web Server, PHP, or Nginx. I have even delved into IFCs to deepen my understanding. After a close review of the Apache source code, I smell something bad in its coding style. Primarily, Apache comprises over 100 modules that have to work together. The source code includes 136 modules, and about half of them are either enabled or commonly used by sysadmins by default. What's more surprising is that they all share a very large structure while working together. The slide shows what the structure looks like, including all elements needed to handle an HTTP request. All modules rely on this huge structure to synchronize, communicate, and even exchange data. An HTTP request will pass through several phases. Modules are acting like players in a game of catch, passing the structure from one to another. When on a module's turn, it focuses on completing its own task, and once done, it passes the structure to the next. This type of collaboration is a common pattern in software engineering. If all modules perform their work properly, the user can enjoy the service provided by the Apache HTTP server. However, any module can modify any value in this structure based on its own preference. While this might be fine with just a few modules, however, if there are over 100 modules today, without any good standard or guideline, can they really work together? Thus, Our research is focusing on the relationships and interactions between these modules. Each module is implemented by different people and subjected to years of iterations and code refactors. Do they really know what they are doing? Even if they do, what about the implementation details of other modules? They need to collaborate with others. If a module accidentally modifies a field it considers unimportant, but the other modules think it's important, it could affect the decisions of that module. Moreover, if they have any misunderstanding on any field of the structure, it can lead to security risks. Starting from the cooperation and understanding among modules, we identified 3 different types of confusion attacks, which are filename confusion, DocumentRoot confusion, and handler confusion. As this is a completely new attack surface, the first person to delve into it can, of course, find the most bugs easily. These confusion attacks led me to discover 9 new vulnerabilities, making me the person currently holding the most CVEs from Apache HTTP Server. Also, because these vulnerabilities are based on legacy architectural issues, many patches are not backward compatible. Updating to the latest version might break all configurations and causes many side effects. Therefore, for many production machines, simply updating to the latest version is not a good idea. Alright, let's dive into our main topic. First, I would like to discuss the attack called filename confusion. This attack occurs when different modules handle the filename field using different standards. Literally, the field filename should represent a file system path. However, some modules treat this field as a URL. This inconsistency in how modules use the filename can lead to vulnerabilities. So, which modules treat it as a URL? The first is rewrite module, which allows sysadmin to easily redirect a URL pattern to any file path or URL. I believe this feature is designed for enhancing user experience. However, this convenience also introduces certain issues, such as the rewrite module treats the target as a URL in all cases. For example, if a sysadmin sets a rule to target the username right after the past user, it fetches its corresponding profile in the file system. So when you access /user/orange, the module will open and print out the file /var/user orange profile .yaml. However, what if you add one more question mark today? %3f is the URL encoded format for it. During the name translation phase, the rewrite module will first merge it into this path. And after that, even if the destination is a file path, rewrite module will treat all of them as the URL and separate the query part by the question mark. So the first primitive is path truncation. You can use a question to truncate the path and access unintended files. For here, we use this truncation to access the secret which is normally inaccessible. And who else treats the file name as a URL? The proxy module does too. At first glance, this seems logical because the purpose of a proxy is to transfer the request to another URL. So when we consider this behavior on its own, it doesn't appear to be a problem. However, if your system relied on the file-based access control, it can be risky. For example, using the files directive to prevent unauthorized users from accessing admin.php. This type of authentication can be bypassed by default when the target is running on the PHP FPN. When you visit a URL like this today, admin.php *000.php. First, during the access control phase, the authentication module compares your file name to admin.php, which is totally different. So naturally, Apache didn't think you need authentication. And then, to support various protocols like HTTP or FTP, the proxy module transformed the file name into a URL and sends it to the backend PHP service. To adapt this behavior, the backend PHP also implements some dirty hacks to handle this unusual file name. It uses a question mark to ignore the query string and passes the original file name for execution. The original authentication required interface can be bypassed with just a single question mark. Of course, it's not just admin.php. Here are more real-world cases, such as the PHP info, which is only accessible locally, and adminer, which is blocked by default. All of this can be bypassed by playing the inconsistency between the access control and proxy module. That was our first confusion attack. It's just an appetizer. Are you ready for more? The next attack I will introduce is confusion on DocumentRoot. First, consider this common rewrite rule. What file do you think Apache will open for the URL? Is it the about.html under the root folder, or the file in /var/www/html? The answer is both will be accessed. Amazing, right? This is also our second confusion. For any given rewrite rule, Apache always tries to access both the version with and without DocumentRoot. This allows us to intentionally access the files outside the web root, especially the root folder. You might be wondering, does this mean we can access /etc/passwd? Yes, but not entirely. We can indeed access, but the request gets denied halfway by the built-in access control module. However, the built-in access control by default allows the access to the folder /usr/share. Therefore, we have a limited escape from the web root. For example, we can use this escape to access documentations on the /usr/share to learn how to use SSH. However, we are still restricted by the file extension .html. You might want to ask, can you access the files outside .html? Of course we can. I'm not sure if any of you have had an idea pop out in your mind. But we can combine what we learned earlier in Filename confusion using a question mark to truncate the path. So theoretically, if the prefix of a rewrite rule is controllable, we can access all files on the /usr/share. Even the tutorial on the official Apache website has problematic examples. So what can we do with this attack? First, we can disclose arbitrary server-side source code. Since Apache decided whether to execute a script or not based on the current virtual host, accessing the full path through a virtual host that doesn't support PHP allows us to easily expose its source code. And since we have broken the trust of only accessing the document root, the entire /usr/share has now become our playground. So the next step is to find out what files under this folder we can exploit. We can leverage existing tutorial examples, unit tests, and even packages from programming language. So this is how developers imagine the library and how I actually use it. Our first gadget we are going to demonstrate is leveraging the library Office, which is installed on Ubuntu desktop by default. We use its help manual for XSS. And we can quickly pop out an alert. Or we can disclose sensitive information. For example, if you have a WebSocket installed, the daemon will by default provide an example file called dumpenv.php. You can directly access this file to print out environment variables. And similarly, the default web loops for Dretty and Nginx are also located on the /usr/share. You can steal data from these web servers easily by a simple rewrite rule. Here we demonstrate how we execute PHP info to leak sensitive information by DevKL. Even some PHP or front-end package like jQuery, MacPy, or JPGraph have tutorials or debug console that can be leveraged as well. For example, we use the tutorial from jQuery feed to read arbitrary file content. By now, you can see that the possibilities of this primitive are huge. Local gadgets are endless, and all that remains is to find more powerful or more universal gadgets. But you might be curious and asking, can you jump out of /usr/share? Of course we can. Apache allows following symbolic links by default. So that is our third primitive that allows us to jailbreak from /usr/share. Also, the folder is theoretically just a read-only copy. The symbolic link inside can still be useful for us. For example, the symbolic link in Cacti, Solar, or even Redmine can be used to jump out of /usr/share. Here we demonstrate an RCE on readMine through a double hop jump. There is an instance folder that can jump to /var/library on the readMine. And within the directory, the config folder can also jump to the /etc/readmine, which contains readmine's database configuration and secret key. So by using an insecure rewrite rule, we can access the secret key used by readmine through a double hop jump. Since readmine is a Ruby on Rails application, the content of secretkey.txt is actually the encryption key used by Ruby on Rails. And the next step is obvious: embedding malicious payload into cookies, then encrypting and signing them with the known key, and get code execution through server-side deserialization. That was our second attack. Are you enjoying? Now let's introduce the last confusion, handler confusion. First, back to our initial question: why can both directives, one for adding a handler and one for adding a content type, can run PHP properly? This is actually due to a legacy conversion in Apache, or you can say it's part of its technical debt. Before Apache enters the main handler for processing the HTTP, if the handler field is empty, Apache will tag the value in the field of content type as the handler. So our third handler confusion is playing around this behavior. In Apache, sometimes the content type can be transformed into the handler that Apache executes internally. So what can this do? Let's show you something fun first. Imagine that your server is running PHP using add type, and you access the file config.php. Since the file extension is .php, during the type checker phase, Apache will assign the corresponding value to the content type field based on your directive. And the PHP knows it's his responsibility to handle this request. The normal process works well. However, before entering the run handler phase, the legacy conversion we mentioned earlier will convert the content type into handler. This explains why both add type and add handler are effective. But what if any module accidentally overrides the content type before reaching the run handler phase? For example, by triggering a filter error in mode security. At that moment, mode security thinks it has made some mistakes and want to send out some errors. Since the error format is in HTML, it sets the current content type to HTML2. And now the config, which was supposed to be executed as PHP, is treated as a plain HTML, exposing all the sensitive content to outside. This is also our first primitive for handler confusion. By abusing old handler conversion mechanism, we can disclose any PHP source code by overriding the content type. Theoretically, all directives based on content type are affected by this issue. But if we think deeper, the nature of this issue is actually there are no clear guidelines for the use of the field content type. It can be set by a config directive during the request phase or used as the content type header in the server response. Apache cannot distinguish which one it is while using the field. Ideally, if we can control the content type, we can invoke arbitrary handler. So, can we really do that? It's very promising, but in reality, the situation is not as simple as it seems. In practice, all the code paths that can modify the content type are all after the legacy transformation. Thus, even if we can modify the content type through the server response, it turns out to be useless. So, what can we do next? Don't worry, we turn to the RFC to save us. RFC 3875 is the specification for CGI. And the section 6.2.2 introduces the local redirect response. The local redirect response works like this. If the CGI returns a status of 200 and include a location header, instead of handling it as a client-side redirect by the browser, the CGI treats this location target as a server-side redirect. Apache's implementation of this server-side redirect will open a new HTTP lifecycle, copying the original field of content type to this new structure. So for example, if you can control the response headers through CGI, that means you can control the content type field. When Apache sees a status of 200, it performs the server-side redirect and starts a new round of HTTP processing. In this new round, the content type header returns by the earlier CGI is pressed into the structure. And after the legacy content type to handler conversion, the content type you provided becomes the handler, allowing you to invoke arbitrary handler. So our second primitive is the ability to call arbitrary handler. Basically, the entire CGI family follows this feature, including but not limited to the WSGI, Fast CGI, and UWSGI. As for how to trigger this server-side redirect, here we provide two scenarios. One is the CRF injection, and the other is the SSRF that can fully control the response header. We will use CRF1 as the example below. First, if you override the content type with a name called server status, then you can leak sensitive information that should only be accessible from localhost. You can also easily transform an image into your PHP backdoor by setting the content type to PHP. You can even achieve SSRF through the proxy module. And this SSRF allows you to control request headers and can read all the response. Super thanks to the convenience brought by the proxy module. The most awesome things about this SSRF is that it can also access the local Unix domain sockets. So lastly, let's demonstrate how to turn this SSRF into an RCE. Here we use a common trick in CTF. The official PHP Docker image by default comes with peer, a PHP extension manager. The peer command is the entry point used to manage the packages. And we can leverage this SSRF to execute the peer command to do further exploitation. For example, we exploit a command injection in the run test command. And we can get a reverse shell easily to execute arbitrary commands. Here my presentation is almost coming to the end, but I want to say, maintaining open source is really challenging, especially for a project that has been around for nearly 30 years. You have to make it convenient for end users and compatible with all versions. The entire development process is built upon a pile of legacy code and technical debt. So if there are any Apache developers in the audience today, I want to say thank you for all of your hard work. Before we finish, let's have a few takeaways. First, the question mark is really powerful. That allows you to truncate arbitrary paths. You can bypass access control and authentication easily by playing the inconsistency between modules. And next, the rewrite rule contains a hidden trap that allows access to the system root. Lastly, by controlling the response headers, you can invoke arbitrary internal handler through the legacy conversion mechanism. There are also some future works. For example, different distributions have different configurations. So exploring such as the FreeBSD or even on-premise applications could reveal more allowed by default ACLs, local gauges, and symbolic links. Finally, due to time constraints, I'm not able to introduce the real-world cases I have found. But you can imagine there must be countless rewrite rules to figure out, ACLs to be bypassed, and hidden CGIs out there. Applying all the techniques we discussed today to bug bounty hunting is now your mission. This is the end of my presentation. If you have any questions, here's my contact information. Thank you for being here again. Thanks.